So let's do this question on question number 10 is on the circle, the equation of a circle. So the equation of a circle is given by x squared plus y squared minus 4x plus 8y plus even 11 equals to 0. Find the coordinates of the center of the circle C1 and its radius. So usually for question 10i, right, the first thing that you have to do is to do completing the square. So you have to complete the square for x squared and minus 4x. And then you have to complete the square second time for y squared and 8y. So that gives us x minus 2 whole thing square. And then I have to compensate it by taking minus 4, right? And next, I am going to complete the square for the y square and the 8y. So this is y plus 4 whole thing square minus 16 plus 11 equals to 0. So this is the compensate for it. Okay, so shifting it around, we get x minus 2 whole thing square plus y plus 4 whole thing square equals to 3 square. So based on this equation, we can see that the center of the circle C1 is actually 2 and minus 4, because what makes this 0? X equals to 2. And what makes this 0? Y equals to minus 4. Then the radius of the circle is actually equals to this base value, which is 3 units over here. So we are done with 10 part I, which is relatively straightforward. So 10i, find the equation of the circle C2, which is a reflection of the circle C1 in the line y equals to 1. So when it comes to this type of question on reflection, right, as much as possible, try to sketch the graph out. So we have the line y equals to 1 over here, okay? And let's write down the center of the circle of C1. In that case, the center of the circle C1 is here. So from the center of the circle C1, right, in terms of the vertical length, okay, it is 5 units away from the horizontal line y equals to 1. Okay, so since the circle C2 is a reflection of the circle C1 in the line y equals to 1, right? This means that for the y coordinate of the center of the circle C2, it must also be 5 units away from the line y equals to 1. So this means that we take 1 plus 5, we get 6 over here. Okay? So then the center of the circle C2 will be here. And this, so this point over here, the coordinates will be 2 and 6. Okay? Which makes sense, right? So that is the center of the circle C2, 2 and 6. And from this, we can find the equation of the circle C2, and we know that it has radius 3 units. So based on the based on the center of the circle C2, we can see that the equation of the circle C2 is actually x minus 2 square plus y minus 6 whole thing square equals to 3 square. And we are done with 10 part 2. Okay? So let's move on to 10 part 3. Given that the line y minus x plus 3 equals to 0 intersects the circle C1 at 2 points, R and S. Find the equation of the perpendicular bisector of the line RS. So for 10 part 3, usually I will advise you all to sketch it out. So we have this circle C1 given by this equation. And then we have our line y minus x plus 3. So So this is the line, okay? It intersects at 2 points, point R and point S, okay? And we are supposed to find the equation of the perpendicular bisector of the line RS. So it's actually a line that is perpendicular to RS and it cuts exactly at the middle between R and S. So it cuts at the midpoint of R and S. So we are supposed to find this equation over here. So what I'm going to do right now, based on this diagram, it should be clearer. So this is the line y minus x plus 3 equals to 0. So we are going to sub this equation. Let's call this circle equation as equation 1. So we're going to sub the equation of the line into the equation of the circle. Okay, so I can rewrite this as y equals to x minus 3. Okay, I'm just bringing the minus x and the 3 to the right hand side. So subbing it inside, okay, we get x squared plus x minus 3 whole thing square minus 4x plus 8 bracket x minus 3 plus 11 equals to 0. So this simplifying, we get x squared plus x squared minus 6x plus 9 minus 4x plus 8x minus 24 plus 11 equals to 0. So this is 2x squared minus 2x plus 20 minus 4 equals to 0. Divide everything by 2, we get x squared minus x minus 2 equals to 0. Factorizing this, we get x plus 1, x minus 2 equals to 0. So we get x equals to 2 or x equals to minus 1. Right. Okay, so when x equals to 2, right, we sub it into the equation of the line here. Y will be equals to minus 1. And when x equals to minus 1, y will be equals to minus 4. Okay? So we have the coordinates of point R and point S. So what we can do is using these 2 points, using the xy coordinates of these 2 points, we can find the gradient of the line RS. So this will be actually equals to minus 1 minus minus 4 over 2 minus minus 1. So this gives us 3 over 3, which is equals to 1. So the gradient of the line RS is 1, and the midpoint of RS, we simply take the sum of the x coordinates of the 2 points divided by 2 and the sum of the y coordinates of the 2 points, and we divide it by 2. So this is equals to 1 over 2 and minus 5 over 2. Okay? So based on this information over here, we know that the perpendicular bisector of the line RS, the gradient will be equals to minus 1. Okay? So we simply take 1, we flip it, and then we put a negative to it. So in case if I'm going too fast, right? So the m of the perpendicular bisector of RS, okay, so the gradient of the perpendicular bisector of RS times the gradient of the line RS is equals to minus 1. And we know that the gradient of RS is 1. So this means that the gradient of the perpendicular bisector of RS equals to minus 1. Right? So using this gradient over here, so we know that the gradient here is equals to minus 1, and we know that the perpendicular bisector cuts through the line RS exactly at the midpoint of RS, which we have found it to be 1 over 2 minus 5 over 2. So using these two information, because the perpendicular bisector cuts through this point over here and it has gradient minus 1, using these two information, we can take y minus 5 over 2 over x minus 1 over 2 equals to minus 1. So this means that y plus 5 over 2 is equals to minus x plus 1 over 2. So y is actually equals to minus x plus 1 over 2 minus 5 over 2. So y is actually equals to minus x minus 2. So that is the equation of the perpendicular bisector of the line RS, and we are done.